Creating a set of blueprints for the construction of a house requires that the architect consider each individual detail. But he must also ensure that everything harmonizes with the overall design. What about the design of life? Do we also see evidence of careful planning and an overall harmony between living things? Our world is filled with marvels of creation, each wonderfully unique. Yet, as we have considered, all living organisms have something fundamental in common: our DNA blueprint. From these incredibly tiny molecules come all the complexity and diversity of life. But even beyond the physical appearance, behaviors, abilities, and instincts of individual organisms, DNA spells out the potential for amazing interactions between different creations. The more we observe the natural world around us, the more we begin to see an underlying harmony emerging from the design of life. For example, many flowering plants produce nectar, which serves as a food for insects and other animals. But the benefit is not one-sided. As bees drink nectar from a flower, they're dusted with tiny grains of pollen and carry these to other flowers of the same kind. Many flowering plants and trees depend on this pollination to reproduce. Yes, by wonderful design, bees, plants, animals, and humans all benefit from this relationship. Hidden beneath the soil, we find another beneficial relationship between plants and fungus. Since they are unable to produce their own food, certain fungi infect the roots of plants and absorb carbohydrates from their host. But instead of being harmful, the fungus can actually help the plant. The filaments of the fungus provide a much greater surface area to absorb minerals and water, which are shared with the plant. Additionally, the fungus can extend into soil that is inaccessible to the roots of the plant. With this assistance, the plant is able to take in more nutrients from the soil, grow faster, and better tolerate extreme conditions. Virtually all plants benefit from this type of helpful relationship with fungus. In the depths of the oceans, we find more alliances between different kinds of creatures, some very unexpected. Groups of large fish gather in areas where smaller, cleaner fish assist them by removing dead skin and parasites from the visitors. Under other circumstances, the larger fish might eat the smaller ones. But at these cleaning stations, the large fish allow themselves to be attended to. Most fish avoid the stinging tentacles of the sea anemone, but the clownfish makes a home right in among them. A special coating on its skin protects the clownfish from being stung. In this way, the clownfish is safe from predators. In return, the clownfish may share food with the anemone and provide protection against anemone-eating fish. Elsewhere, a goby fish and a shrimp live together in the shrimp's burrow. To protect its nearly blind host, the goby stands guard and taps the shrimp with its tail to warn of danger. These are just a few examples of the interconnections we see all around us when we look more closely at the natural world. How do these instinctively wise creatures know to form partnerships with others so different from themselves? Somehow, the potential for these relationships is recorded within the DNA of each one. Yes, life is not just a random collection of individual creations, but rather a marvelously orchestrated masterpiece of design. Each living thing plays its part in perfect harmony with others around it, joining together in the magnificent symphony of life. To learn more about creation is to gaze in wonder at design and engineering far superior to anything mankind has devised. It is to catch a glimpse of the mind of the master designer Jehovah God.
Colors fade on man-made materials. For example, paint and clothing. Yet, for many species of birds, this isn't the case. Their feathers remain permanently bright and vivid. What's their secret? Researchers, examining the feathers of the Eurasian jay, discovered their colors are generated primarily by small changes in feather structure, as opposed to pigment. Surface variations scatter the reflected light, which produces the hues we see. And since this structure doesn't change with age, the colors never fade. This discovery opens a whole new world of possibilities. Dr. Andrew Parnell states, if nature can assemble this material on the wing, then we should be able to do it synthetically. Researchers are now working to produce materials that mimic this. This could lead to paints that never fade, and perhaps even fabrics that look new and vibrant, wash after wash. What do you think? Did the unfading color of bird feathers come about by evolution? Or was it designed? Sharks have skin that protects them in a unique way. Left unchecked, microorganisms would establish colonies on the shark's skin, which in turn would attract larger parasites to latch onto the shark. If that happened, the shark's health and ability to swim would suffer. But the fact is that the shark's skin remains virtually free of parasites. How? Shark skin is covered in complex scales called dermal denticles. Though they look like tiny fish scales, they are built more like mammal teeth, with a smooth enamel surface. This very smooth surface, together with a complex structure of tiny ridges, makes it very hard for microscopic organisms to grab on to the shark's skin. If one does latch on, those same ridges channel water to flow faster and wash off the hitchhiker. So this single design element resists parasites in two different ways. But that's not all. The denticle's unique shape creates small areas of suction all along the shark's body, enhancing its ability to thrust itself forward as it swims. These advantages allow sharks like the short-fin mako to reach burst speeds of 74 kilometers per hour. Scientists are engineering artificial surfaces that mimic shark skin to help boats and planes be more fuel efficient. This nature-inspired technology could also prevent harmful germs from growing on hospital surfaces without having to use toxic disinfectants. What do you think? Did shark skin simply evolve? Humans have a fascination with flying. But for many who fly small aircraft, the smaller the plane, the greater the instability. Yet, the tiny bumblebee is capable of flying with unmatched stability in strong winds. How does such a small creature outfly even the most experienced pilots? The bee will reduce speed when it encounters wind turbulence, allowing it to focus its energy on correcting its flight path. Additionally, the bee is more susceptible to flight disruption when the wind blows against it horizontally. So, another key to stability is that it will roll mid-air into the force of the wind. This repositioning allows for better control, as the bee can easily adjust to oncoming vertical turbulence. Understanding the bumblebee's innate control system could someday help aeronautical engineers design small aircraft better suited for stable flight in adverse weather. In the meantime, scientists still have much to learn before practical application is possible. What do you think? Is the bumblebee's impressive ability to fly in turbulent weather a product of evolution? Or was it designed?
The Earth has more than 350,000 species of flowering plants. Flowers serve practical needs. Flowers make pollen in order to reproduce and nectar for creatures that spread pollen. Pollination produces nutritious seeds, fruits and vegetables. The beautiful flower we see may look like this to a bee. Some flowers reflect ultraviolet light in ways that create a hard-to-miss target. We enjoy more than the flower's beauty and aroma. Yet some plants do not need beautiful flowers to reproduce. Flowers, pollen, nectar, and aromas are costly for plants to produce. Those resources could be used for other purposes. Yet plants make flowers in breathtaking abundance. Jehovah generously created flowers in a way that brings us joy and reminds us to trust Him when we are anxious. Take a lesson from the lilies of the field, how they grow. They do not toil, nor do they spin. But not even Solomon in all his glory was arrayed as one of these. Our tongue can detect 5 basic tastes. There is sweet, salty, sour, bitter, and a rich, savory taste called umami. But we enjoy not just 5 flavors, but possibly over 100,000. How? As we chew, we also smell our food. Chewing releases aromas that pass up into our nose through the back of our throat. Taste and smell then combine to make the flavors we enjoy. Our taste buds develop before we're born. As an unborn baby swallows amniotic fluid, it may taste what its mother eats, and is more likely to enjoy the same food she does. We don't eat just to survive. We love to eat. It makes us happy. The Bible says why. That everyone should eat and drink and find enjoyment for all his hard work. It is the gift of God.